review. Let's get started. So it starts out with just one of our graphs, and it's the reciprocal graph, y, or f of x equals 1 over x. And you can see the graph is given to you in this situation, and they're asking what is the domain. Remember, this is asking how far left does it go, how far to the right does it go. Well, we've got two chunks. We've got chunk A and chunk B. So let's talk about chunk A first. You can see that it's an asymptote there, which kind of heads to here. It's coming up to the x-axis, but it doesn't touch it, and that's the same thing for this. So we know that y equals 0 is one of our asymptotes, and seeing we're talking about it, let's go ahead and talk about this one, because I think it's a wise thing to do to start with the asymptotes. We've got this vertical line right here, which is the y-axis, which has a name, x equals 0. So there's our asymptotes, which helps us with our domain, because this thing going to the left is going to go on forever to the left. So x is greater than negative infinity, but then it tries to get to 0, but it doesn't get there. And then together with, and then there's another piece to this that's right here. Again, as it goes to the left, it's trying to get to 0, and then it goes to the right all the way to infinity. And how about the range? Well, the range, we're going to start with chunk A. How low does it go? Well, it gets down to infinity, tries to, negative infinity, and then it gets up to 0. Together with union, y, and then this one right here tries to get down to 0, and then goes up to infinity. X-intercepts, well, because this is trying to touch it but never does, there aren't any. Same thing goes with this. Same thing with the y-intercepts. Because these are the asymptotes, our graph never ever crosses it. So y-intercepts, they don't exist either. All right, now we're to the algebra portion. Okay, so honoring just your basic rules of PEMDAS, we know we should simplify things inside parentheses first. You can't simplify anything inside, neither places. So we got to go to our exponents first. The danger is to start canceling things out before you deal with this exponent and this exponent. So let's just go nickel and dime this thing. Negative 3 cubed is negative 27. Power to a power, you multiply. Power to power, multiply. Same thing down here. X, there's an invisible 1 here, so you multiply the exponents, you get x squared. Y to the 6. You can notice these just cancel because they're the same. So we end up with negative 27, and then you got 9 x's in the top, 2 x's in the bottom. 9 minus 2 is 7, so x to the 7th. Pretty simple stuff. This one, remember, this is our index. Whenever you have a fractional exponent, this is our index, and it's always wise to start there. So it's a cubic root of 125, which is 5, and now we square that, so we get 25. Now we've got bite-sized pieces. There's an invisible 2 there, so we know we got to break that 32 up into the product of 2 square roots. That's number land. Here comes letter land. When we have x to 11th, we think, what's the first number less than 11 that 2 goes into? And that's 10. So we pull off 10 of those, and we're left with 1. So here's my perfect square root. Here's my perfect square root. Number land, letter land. Well, the square root of 16 is 4. 10 divided by 2 is 5, so it's x to the 5th. And then these two smash up against each other, and you get that. And there's your final answer. And this 5 goes with the x. That's not an index. This one right here, well, this is a binomial squared, so we have to just follow the rules and square the binomial. So here we go. First, outside, inside would give me negative 4x. I'm just speeding that up. Negative 2 is positive 4. The danger here is students will square this and just square this and think they got the right answer, but that's incorrect. You got to FOIL it out. All right, here we go. Number 6, more algebra. So when I look at this, I think about this right here, and I think, all right, let's get that square root out of the denominator. So what do we get? We get 4 square root of 3 all over 3. And then we've got this negative 2 square root of 3 thing lingering. Well, now we got a need, because we have common radicals, to get common denominators. So what is this? If I put it over 3, it'd be negative 6 square root of 3 over 3 plus 4 square root of 3 over 3. And now we've got common denominators and like radicals, so we can go, aha, negative 2 square root of 3 over 3. And there would be your final answer. Be careful that this is completely reduced. Don't put your answer down until you reduce that, which it already is. Number 7, it's a similar problem to number 6. You just have to add. You're like, well, you can't. Well, you're right. You need common denominators, which is going to be x plus 2. So here's the trick. We're going to multiply this by x plus 2 all over x plus 2. And then now we have common denominators, so that we can proceed. So we distribute this and distribute that, so we get 4x. And remember, what does this equal? This equals 1. So we're not changing the value of the problem, we're just changing the way it looks so that we can obtain common denominators. So 4x plus 8 all over x plus 2 plus 8 all over x plus 2. Common denominators, the denominator doesn't change. Numerators, we add, and we just look for like terms. And you got to be careful with these, because you should, for your final step, think to yourself, okay, a 4 can come out of there in this instance, and you better factor it, because you never know, because if this thing ends up equaling this thing, then you would cancel them. But obviously they don't, so we're done here, which means you could have been done here, but there's a danger in stopping here. So be on your guard there. Okay, just dealing with functions here. So it says if g of x equals this, evaluate g of x minus 1, which simply means take that x minus 1, put it into the function described by g wherever x shows up. So it shows up here and it shows up here. So I got to take x minus 1, put it in there, so I get x minus 1 squared, but I also have to put it in there, plus 3 times x minus 1. Again, this is kind of similar to this problem up here, where you have to just know what you're doing, where you have to FOIL this out, x minus 1, x minus 1. So that's x squared. I'm going to go outside, inside, minus 2x plus 1. Oh boy. So then I distribute this and distribute that, plus 3x minus 3. So I get x squared, and then this and this gives me a plus x, and then minus 2. And this would be my final answer. Okay, number 9. So it says solve for y. So essentially, we just need to take this problem and solve it. So here we go. Let's start with the 3, distribute it in there. So 0 equals 3 plus 3y squared plus 2y minus 6. You can see a trinomial's lurking. So 3y squared plus 2y minus 3. Now you could spend some time and try to factor this, but I'm just going to use the quadratic formula, and this formula is in your formula sheet. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So that means take the opposite of b. So negative 2 plus or minus means we have two answers. B squared, 4, minus 4 times a times c, all over 2a, which is 6. So let's clean this up. I can see two negatives, so that's going to make positive. And so 4 times 3 is 12, 12 times 3 is 36, 36 and 4 is 40. So negative 2 plus or minus the square root of 40 all over 6. Now, unwritten rule in math, you don't leave your answer like this until you're satisfied that it's been completely reduced. And you can see the square root of 40 can reduce to this, which is negative 2 plus or minus 2 square root of 10 all over 6. Now notice this and this and this, all three of those can be reduced by a factor of 2. So if 2 goes into all this, I get negative 1 plus or minus 1 square root of 10 all over 3. Now if you're on a multiple choice test and you see this thing, you better circle that, because this is the same thing as this, because you can write them separately if you want. Either one is fine. Okay, so number 10, there's a lot going on with number 10. I've just blocked off the graph just so our mind doesn't wander. Let's just tackle the first set of instructions. Find the inverse function if f of x equals square root of x plus 1 plus 1. So if you remember, in order to find this, we've got to take the original. We know that this is y, so that's y equals the square root of x plus 1 plus 1. That's what f of x is. But in order to find the inverse function, we need to switch the x and the y's and then solve for y. So x equals the square root of y plus 1 plus 1. But remember, we got to solve for y. So we're going to subtract 1, subtract 1. I'm going to flip this around. Square root of y plus 1 equals x minus 1. We got to square this side and square this side. Remember, you can't just square this individually and that individually. That's a very common mistake. The roots fly off of this one. Y plus 1 equals, now that's x minus 1 times x minus 1. So that's x squared. Let's go ahead and just put it here. X squared outside inside minus 2x plus 1. Now we're going to subtract 1, subtract 1, and we would get y equals x squared minus 2x. Now, we know this doesn't equal y because this equals y. We switch the x's and the y's, so we take that out. We think, aha, this is now our inverse function. Now, it does say, after finding the inverse function, which we have right here, sketch the graph of f of x, meaning this one, and then sketch the graph of this. Now, you might think, well, those are two independent things, and they are, but they're not. Now, I'm going to try to explain that. So the first thing I'm going to talk about is this, and we have to understand that the parent function is y equals the square root of x. Now, if we think about that, if we get that going, I'm going to do this dotted. I'm graphing this. If I put it, remember, x cannot equal any negative numbers in our domain. But we should have this somewhat memorized by now because we've been dealing with it. But again, let's just talk some common sense. So if I put a 0 in, I get 0. If I put a 1 in, I get a 1. If I put a 4 in there, 1, 2, 3, 4, I'd get 2. If I put a 9 in, I'd get 3. I'm just picking perfect square roots. And you can see what this is going to look like. Okay, so now to graph this, I'm just going to obey its rules here. This means take that green one, move it left 1, and then move that up 1. So this one, going to go left 1 and up 1 and just try to duplicate it. So left 1, up 1, everything. Left 1, up 1, left 1, up 1, left 1, up 1. And then you can see, trying to do this really carefully. So there's f of x. Now, it says, now graph this. Well, remember, you could just take your time and graph this using, this. You could complete the square. But really what you're supposed to remember on this, and I'm going to use a blue marker here, the inverse function has everything to do with y equals x. Y equals x looks like this. It just does. And if you remember your rules, the inverse function flips this original f of x over the y equals x. So that point right there is negative 1, 1. And what you do, remember what we did, we literally did it, is we switched the x's and the y's. And that's literally the definition of an inverse function. So we're going to switch these for our final answer, which I'll make pink. And we'll just switch these just to get started. So it'd be 1, negative 1 as our first point for our pink graph. So 1, negative 1 is right here. It just takes that, flips it over the y equals x. And then you can kind of see the pattern here. That point right there is 1, 2, 3, 1, 2, 3. So if we flip those That's actually supposed to go right through there with the y equals x. That's our kind of meeting place, and then everything else just kind of spins off, and there we have it. There's our inverse function, just over the y equals x. It's a lot easier than actually taking that time to graph that. Okay, that took a while. We're going to call that part 1 and just finish it. See you on the next problem.